So my name is Florian. I've been a software engineer for now 15 years almost, and I do mainly mobile. And most of the gigs I've had in the past were at smaller companies. So we had maybe a team that was up to like 15 people, and that changed when I joined Qonto, where we operate at a different scale, which means there's a lot of interesting challenges that popped up. And today I'm going to concentrate on the challenge regarding debt. Just a quick word about Qonto. So Qonto is making the day-to-day of banking easier for SMEs and freelancers, for smaller companies. We offer like a online business account and all the tools that go with it, so invoicing, bookkeeping, spend management tools. We have a clear pricing and awesome 24/7 customer support. So that's what we do. And for a bit of context, this is our team as of last week. So we have 58 engineers and 9 leads. So leads is, in our jargon, is engineering manager. We have roughly the same on iOS, and we are split in 13 teams that are themselves split in 4 domains. So you can see here a bit of the scale in terms of people, and in terms of more technically in terms of code base. We have almost 1,000 modules by now. We have over 1 million line of code, and we are shipping something like 300 PRs per week. So that's quite some code. And that puts us in an interesting position because we're obviously not really a startup anymore, but we're also quite far from big tech, right? So we cannot just throw 10 people at a problem for the next 6 months. We need to ship, we need to, for our clients and the product. So we don't really have this kind of resources. So we need to be somewhat smart with what we spend our non-feature time on, and be quite efficient and cheap also in terms of cost. And this means we are slowly hitting also interesting scaling issues. So if we go to the actual problem here, let's start by saying you're just joining Qonto, so you're a new engineer. You start by obviously familiarizing yourself with the code base, understanding how people work, what's in there, what we use, how it works. And you get used to how your team operates as well, right? And so you start then in a month or 2, really shipping features with the right amount of speed and quality. And so all good there. And obviously because you care about the code base and the code you operate in, and that your team own, you also clean up the code as you go. But there's a bit of an issue here is how do you know actually that the code that your team is owning is doing good, right? Is it up to standards? Is there an issue in there? What are the most pressing issues to solve, for instance? You might have some architecture problem, or you might have some things that you really need to work on because you might be the one team that's blocking the end of an important migration, for instance. And probably like some of you in there, we also have this tool, SonarQube, and like, great, I'm just going to check on SonarQube what kind of code smell there is in the code that my team own. You go on SonarQube, you see you have 2,000 open issues, awesome. And then you click on it and you see a breakdown of the issues and you're like, great, but like what issues are in the scope of my team, right? I cannot operate in the entire code base, it's huge. I want to fix what my team owns. And this is not something that's easy. This is not something you can really visualize. I mean, you could click more and then go module by module, but this is just really tedious and hard to navigate. And the consequence of this is that it's quite discouraging, right? How can you fix something you cannot really visualize, right? So you know there's issue in the code you own, but you cannot visualize them. You don't know where they are. And the debt doesn't decrease. Worse, it increases slowly but surely. And so you have this endless discussion every week at the weeklies or whatever ceremonies you have. We will have this discussion about the code base where it's like, our debt is growing, there's debt, what should we do? And the hard truth is that when debt is everyone's problem, it's also no one's. So this is the interesting state of the number of issues we had in the code base. So by issues, I mean things that were flagged by our static analysis tooling. And you can see that it's growing quite a bit as we scale up, and it's definitely not going down. So what you see at the end is in 2024 at the beginning. So how do you find and how do you build a solution for that problem? The first thing we ask ourselves is, what do we actually want? What do we actually want to solve? So we want to improve the ownership of the debt. We want that every team own their debt and is actively working on fixing it. And for this, we need to enable them to be able to visualize it and also to prioritize it, right? We don't want, I mean, we want that the team really put effort on things that have meaning and will have an impact, and not on like random bits and pieces. And obviously, the end goal is to reduce the debt and be able to ship faster and with more quality. But as I mentioned, we are not big tech, and we do have still quite some constraints. So we wanted to start with something that's really cheap. We didn't want to go and start to like buy a lot of tooling and work on something for 6 months and then hope that it will work. So we wanted to start with something that's really cheap. We wanted to get this first version out fast to understand if this works, if people are using it, and if not, what's wrong and how we can fix it. So the same without going 6 months and then be like, oh, actually we spent 6 months working on this thing and no one is using it. And also, obviously, bringing some value straight away. So having this iterative approach where we bit by bit bring some value for the team. And so for this, we need to talk about a few components of that problem. So one of the interesting problems we've had is the ownership, right? How do you know who owns what? So before we started this, we had a basic understanding. Whenever we were creating new module, we were adding a README file that had the name of an owner. But looking at that, we saw that we had 20% of our module that did not have an owner. I mean, they did have an owner. It was called the Android team, which means that if it belongs to everyone, then no one is going to fix it. And at the time, we also had a big monolith that had no ownership, but contained 23% of our code base. So we were kind of like blocked straight away, but then we realized that's actually not the goal of the initiative, right? We don't want to fix every ownership issue, and actually we can use this initiative to kind of like make the lack of ownership visible. So we will just start with the ownership we have, and then make the lack of ownership visible, and then carry on. And the second question is, where do we get these metrics, right? So we started with the output of our static analysis tooling. So we have detect, we have Android lint, and we have also quite a few custom rules that are good for our context at Qonto and things we want to work on. And we wanted to have a solution as well that would be flexible enough to allow other types of debt in the future. But where do we get this data from, right? So the option one was to just build something custom. There's a really great talk on how they did that at Slack that you can check out. But for us, as I mentioned earlier, it was too much upfront effort and cost. So we wanted to really start small, bring the value fast without spending quite some time building something custom first. And for this, well, the solution was right in front of our eyes. Actually, we already use SonarQube. They have OK API where you can get like all the issues with all the details. We already pay for it. It has all the data we need. And it already consumes all the rules we had, so the custom lint rules, the detect rules, and all that. And then how do we display that data, right? So at Qonto, we have Notion. So we actually use Notion for everything, which is quite interesting in a few different ways. But at the time, it was not really handling graphs or display of data. And then we would also need to have all this like extra synchronization between our database and Notion. And in the past, we had some issue with reliability there. So that was not really a great option. And the second option is to use Metabase, which is a tool we already use. It's quite powerful. You can just like create like a lot of graphs, and it's already connected to our database, and it's really good at data visualization in general. There will be a demo after, so you can see really how it looks like. And of course, because, Mr. Slide. So if we summarize this, what we wanted to do is we wanted to empower each team to be able to visualize and act on the depth they own. And to do so, we will leverage then the data from SonarQube, format and store it in our database, and displaying using it dashboard on Metabase. Because any project of this caliber needs to have some definition of success. We set 2 for us, so quite intense ones, but achievable. So 90% of the teams reduce their tech debt by 50% in the next 6 months. And the second one was that we want to stop doing manual tracking in the code base for wide migration, right? So we had this problem that when we wanted to do a migration, we always had to go in the code base and kind of figure out where everything was and kind of maybe put it in a Notion database or an Excel sheet. And obviously the code always moves because teams work on it, and it was just a nightmare to track. So we want to be able to look at something that tells us, okay, for this migration, for this issue, you are 15% done. Here is the issue that are left, the team that still need to work on that. And to show a bit how somewhat simple the solution we've had is, so basically what we've done is that whenever we merge data, I mean, it's already in place. When we merge code, the data is uploaded on SonarQube regarding any issue we had, and we just added a CI job that will run after that, get the data from SonarQube, format and store it in our mobile metric service, which is our database, and render it using Metabase, and then anyone can have a look and visualize the data. This is my awesome drawing skills. This was just to visualize a bit how things would work, what kind of views we would need, how we would navigate things, and in the demo I will go a bit more in detail. So this is the first POC we've had. So this tool is not something I built myself, right? The whole UI is what it's the Metabase tool, so you can create this, what they call this question, so it's each of this block, and behind this you have a SQL query, and then that's how you display the data, and then you can put some fancy UI, and you can also click through and whatnot. So the first iteration was really basic. We had this global view where we could see all the teams. Every time there was an issue, we would -1 the score. And what's interesting as well, as I was talking about at the beginning, to the surprise of no one, the code that is not owned is actually the one that is doing the worst. And so we highlighted that code by creating this no-owner team, which was in the face of everyone that we would need at some point to fix that ownership issue as well. And then you can start by this global kind of dashboard where you can see a bit how every team is doing, and then you can click through at the team level and see what issue they have, maybe which module has the most issue, and then you can click through up to the module level, and then the file level, and then the most interesting view for us to track migration is this one. This is where you can see, okay, I'm 15% done with this issue. There's still a bunch of issues left, and here is where they are. So this was really, really useful. So we built this first prototype, I think, thinking about how we are going to do it and executing it in a bit less than 1 month with one engineer. And then we wanted to kind of beta test it and get early feedback straight away to make sure that we are going in the right direction, that people were using it. And this was actually solving the issue we were having. So we tested it on a smaller subset of teams. I think we had 2 or 3 teams. We gave them a bunch of tasks to do on the dashboard. It's okay, try to find, this particular issue, then try to find it in the code and fix it. We gathered some feedback from all the stakeholders, so mainly the ICs and the engineering managers. We implemented some of the low-hanging fruits from the feedback we've had, and we log the rest for later. We find also a nice name that sticks. I mean, it's a pretty long name, but people actually now know what this means and use it quite a bit. So that's how healthboard. Is that it? Yeah. Okay, awesome. And now let's take a bit some time to talk about the adoption. One thing I didn't mention as well, I was quite nice when we did the beta testing, is that actually the dashboards leaked to other teams. So other teams started to use the dashboard even though they were not supposed to be in the beta testing. So that was a good early sign that we were doing something good. So in terms of communication, it was pretty basic, but we created a dedicated channel on Slack. We had the cockpit, which is basically a big page with that link to everything related to the health board. We wrote some documentation on how to participate, how to write issues, and whatnot. We communicated a lot in our weeklies. We made it so we communicated about how useful it was rather than please use it. So what we've done is we were sharing wins. So we had top 3 every week with the teams that solved the most issues. We were highlighting also whenever migration were done or about to get done. So every week it was reminding the team that we had this tool and that it would be awesome to have a look and fix some issue yourself. We also listened to feedback quite a bit and log any improvements and ideas that people had. And we put also in place a bit of gamification, which is quite interesting. So we had this system of badge. So if a team would fix a type of issue in all their modules, then they would earn a little badge. And it did work quite a bit on some engineers that got quite competitive. So that was an interesting take from that as well. We then iterated a bit on the score. So as you've seen, we had this score that was a bit awkward. It was just okay, my team has a minus 500. What does it mean? Is it good? Is it bad? So we introduced a 0 to 5 score. That was a lot more readable. We also made it more fair, right? We had new team that maybe had 2 modules of really fresh code, whereas we had really old team that's been there for 7 years and had hundreds of modules. So we kind of computed the score depending on the amount of code this team had. We introduced coefficient as well. So that was really helpful to kind of prioritize type of issue we wanted engineer to work on. So obviously it's not really fair to have, I don't know, a unused import having the same priority that maybe fixing something that we need for next month because we need to ship something specific. So we played with coefficient to make sure that the issue that had the most priority for the whole team were at the top, and that if people solved this issue, then they improved a lot more their score than if they fixed random little detect issues, for instance. And we also, what was interesting is that when we started to visualize all these issues, we realized that some of them were pretty useless in our context, and we didn't want engineer to spend time on that. So we created a little committee that went through all of these rules and decided the one that made sense for us and the one that didn't, which means that now we have a health board that's really focused on what we feel is important to fix in the debt we have at Qonto. One important part as well was involving the team. So I was pretty alone at the beginning on that project. There was a few engineers here and there that joined for a couple of weeks to help me on one feature or another. But we felt that if we really wanted this thing to take off and people to get involved, people to really use it, we wanted to have people involved. So we encouraged the ICs to write their own rules. We provided support. We helped them. We supported engineers to build around the health board as well. So as I was mentioning, at the beginning, we had this one type of debt, but we had also engineers that were really into, for instance, UI test, and that added some dashboards around flaky UI test or UI test that needed to be migrated to our new framework. So it was quite interesting. We also made it a lot easier to report issues. So one thing we've seen is that a lot of this issue we had was just code that was deprecated and people didn't want to use anymore because there was maybe a new API or something better to use. So we just created a little annotation that you can just slap on a piece of code that shouldn't be used add an ID, and that was it. The issue was on the healthboard. And so if we look now at the results, so we achieved our definition of success for this one in less than 3 months, which is like twice as less as what we thought. So it was really encouraging. We also managed to have real-time updates. So whenever the code gets merged, it updates automatically the data. So we have really like a tracking that's on the dot where we can see, okay, this migration is X% done, and there's no manual Excel sheets or Notion database to maintain anymore, which was a huge win. All right, it's time for demo. That's where everything goes wrong. So this is how it looks like today. I'm sorry it's a bit small maybe, but what we have here is that this is the global one. So we see on the left, we see all the teams, all the modules, and kind of like a tendency of how the debt is doing in the last 30 days. Yeah, yeah, that's better, right? Awesome, cheers. And then we can also check these 2 new tabs that's been added by some of our engineers. And so we have this UI test tab where we can see we are currently migrating to a new homemade framework for our UI test. And we can see each team and the progress we've done. So we can see that here we are almost there. There's this one team that needs a bit of support to finish the last few tests. And we can see also all the flaky tests that teams should be looking at. Because like everyone here, I assume we have also flaky test issues. And we also have a new tab regarding dependency. So for dependency, we also have this concept of ownership, which means that each team is responsible to keep updated some of our external dependencies. And so this is like the global healthboard, but what's even more interesting is when you dig in a specific team. So that's what most engineers will look at. So when you look at your team board, then you can see your score. I was mentioning this earlier, the little gamification. So we have a bunch of badges here that they got by fixing an entire type of issue in their scope. And then the same, we can see the issue here. So this team is doing quite good. So the main issue they have is only of a coefficient 2, but it's at the top. How each of their module is doing, and the same with the UI test. So here we have 2 flaky tests to fix. They are done with the migration, and they are also good with the dependency. So it's a really quick way for teams to be able to check how they are kind of like the code they own is doing. And the most interesting part is this one, which is focusing really on a specific issue. So for instance, recently we created a rule to flag some of the on-back press issues, because this is something, on-back press deprecation, because this is something we need to fix for 117, I believe. So it might be a bit early, but the earlier it's done, the better. And here we can see that we are 50% done, and that there's only 25 issues left in a couple teams. And we can even go further here by looking at, in which team there's still some work to do. And we can see also the issue count by module, if that's interesting. I create also this question here that's maybe a bit intense, but it's quite interesting to see which team kind of like started on fixing this issue, and maybe which team didn't and are not aware that's in there. Maybe they need a ping, or they need some extra help to tackle it. Another thing also that's quite interesting is that to reduce a bit the friction, if I click on a specific issue, let's go in this module. Where is it? I need to go at the file level, sorry. We have a little button here that says C in Android Studio. And this is actually a deep link that goes directly in Android Studio, in the right file, on the right line. So it sounds quite small, but it reduces a lot the friction of, going there and being like, okay, this is in whatever view model at whatever line, and then going in Android Studio and then typing that file and going to the right line. All right, that's it for the demo. All right, let's go with the learnings now. So what worked quite well is that we really took the challenge iteratively, right? So we started really small. We were having something where it was just bare bone listing the issues, and then we really checked that the value was there, and if not, what we could do about it, and then we built the rest on top. So this project started early 2024, and to this day, we're still adding more and more type of that and feature on top of that, that tool. So don't underestimate the small features that reduce friction. That's what I was just talking about. This little button is like the engineer's favorite feature of the healthboard. This saves a lot of time and frustration. One thing that I think worked quite well at Qonto, but you might be a bit careful at your own company and in your own context, is to really look at the healthboard as, and especially the score, as an indicator that a team might need support and not that a team is lazy or not doing their job. So we definitely use that as an indicator and be like, okay, this team has actually a lot of modules they own, they have a lot of debt, they don't have much people, they are really focused on feature at the moment, and we still need to go through that migration, and then we will put some extra effort from other team and help them rather than telling them to go faster or to do their job. Yeah, what was quite interesting as well is that AI is actually really good at SQL query. So that was a huge part of this work. I would say it's like maybe 90% SQL query and 10% scripting. So it's really, really good. You can give it the schema. You can be like, this is what I want to visualize. Please give me the query. And in 95% of the time, it just worked, which was awesome. What we adjusted, so at the beginning, we were kind of like adding new issues all the time, changing coefficient all the time, and it meant that the score was fluctuating quite a bit, which was quite frustrating for the teams, because they would maybe achieve some kind of milestone where we fix a lot of issues, and then the next day we were like, okay, actually we need to add like 5 new issues, and then their score would not budge. So we realized that the teams needed some predictability, and what we're doing now is that we are evaluating coefficient and issues, new type of issues every quarter. So we start at the beginning of the quarter, we set the new score, and then the team has like a full quarter to work on that score. It's also quite helpful because we have some engineering manager that start to put kind of like some incentive for the team to reach a certain score at the end of the quarter. That was also something I learned, is that I got quite overwhelmed with the number of requests and ideas that people had, and I really wanted at the beginning to implement every single thing, but it got really overwhelming. And what worked really well actually was to log the request and to be like, okay, you want this feature? Okay, let's do it together. And by doing this, then I managed to have a few engineers that were really into the healthboard, that knew how it worked, and that could themselves help other people or build on top without needing my full support. So kind of like enabling the team to also be able to participate to that tool. What we are still figuring out, so how to write a good rule. We've had issues with a few rules where people write a custom lint rule that would flag thousands of issues, and I would really overwhelm the team and not be super helpful. For instance, we wanted to move from GUnit 4 to GUnit 5, and so we logged every single import that were from GUnit 4. But this meant that in a single file, we could have 15 issues flagged, which was not super helpful. And then by taking a step back, we realized actually what we want to do is we don't want to flag the imports, and we don't want people to fix import by import, but we want people to fix like a whole test file. So we rewrote the rule and instead just flagged one issue per file that was still using JUnit 4. But we are still figuring this out because we still have people that want to, for instance, flag all the deprecated calls in the code base, but is that really helpful? Should we maybe categorize those? So there's all these interesting challenges that we've had as well. And that's what I meant, so make sure that we don't overwhelm engineers with thousands of new issues to fix. And some of the teams are also not as focused on the healthboard as others. But I think this is also related to, we've had quite some chat with them, and this also relates usually to the amount of work they have, or if they're, they have a very important feature to ship. Yeah, we're making progress there, and we're talking with them and understanding why it doesn't work as much and how we can, make things different. In terms of the future, so what we started doing with iOS, for instance, is we have a solution that is actually quite language and platform agnostic, right? Which is basically consuming issues on Sonar and putting them in the database. So theoretically, no, this was the second line, sorry. I'm going to start with this one, super overstacks. So we're supporting iOS at the moment to integrate this as well, because the solution here is quite agnostic. So technically, we could use it for web, iOS, and backend. We're also looking into integrating other dimension of the debt. So for instance, the app size, that would be an interesting one for each team to know which amount of app size they contribute to the code base, and maybe for them to work on reducing that amount. We've also started to have the health of the modules, so to understand if a module, for instance, has a lot of dependency, there's probably a problem and some inversion to do, or some maybe splitting. So each team now can see how their modules are doing and maybe the one they should concentrate on. One idea we have as well is I was talking about friction earlier. At the moment, it's still quite some friction because you have to go to Chrome, and then you have to find the issue, and then it goes back to the IDE, and then you have to go back to Chrome if you want to fix multiple ones. So one thing that would be awesome is just to integrate it in our IDE plugin. We have a little IDE plugin. And so engineer would be able to kind of see all the issues and fix them straight up inside the IDE without having to switch focus or go somewhere else. Obviously, because in this day and age, I cannot have a talk without talking about AI. We're also looking into how we can automate some of that debt reduction. So the phase one that we have, and it works, is we are able to visualize everything. We started to automate the easy ones. So for instance, we have now a CI job that runs every week and fix all the detect one that can be fixed with the autofix tool. And ideally now what we want to do is to be able to automate the fixes by using AI for some of these issues, right? Because the more time engineers spend on this, the less time they spend on making great feature for our clients. So if we could automate this debt reduction as much as possible, that would be awesome. And so for this, we have a bunch of ideas, right? It would be quite interesting to have, for instance, MCP, where we could say, okay, please fix this type of issue in my context, and then it would automatically kind of get these issues from the health board and go on and fix them. For this, we could add, for each manual custom issue we create, we could add a prompt where we could say, this is how you fix this type of issue. This is a few commits where we've done the work already manually that you can check out to understand how to fix them. And then we could run this, for instance, on the CI, and it would just open the pull request, and you just have a look, merge, and you're done, right? So here we would just, as human and as owner of the code base, we would just have to review the removal of the debt without having to really do it ourselves. Because let's be honest, quite some of these issues to fix are not that interesting or not that hard, right? Usually just a little nudge or something. So as a conclusion, what worked really well for us is to really use the tool we already have and that are comfortable with. So we didn't have to go kind of like to our stakeholder to buy a new tool. We didn't have to learn a new tool. We didn't have to install some new tooling in our infrastructure. It was already all there, and we just had to use the APIs. We started really small, make sure that we were bringing the value we were expecting, and then validating that and iterating. And communicate a lot about the tool, not just please use it, but actually showing the benefits they have, and listen to people who want to help and support them to kind of like enable this multiplier effect where everyone is feeling responsible for the tool and want to help and want to add new features. And I'll finish on this slide. So that's the slide I showed at the beginning. And this is 2 years later. This is how it's going. So that was pretty satisfying to see. And on this note, I will be hanging out a bit here if you have any question. Otherwise, you can catch me at the conference. And I'm happy to talk about the project or show you more or answer any questions. Thank you.